During the IPL Final, Hotstar served 50 million concurrent viewers, every single one of them pulling video chunks simultaneously. No server on earth can handle that load. So, how does Hotstar stay online? They stop using one massive computer. They start using thousands of smaller ones, working together. In this video, we cover what a distributed system actually is. We break down why vertical scaling always hits a wall. We confront the hard truth. The network is not reliable, and we unpack the CAP theorem, the ultimate trade-off in system design. Let us begin. When traffic spikes, the simplest solution is vertical scaling. You scale up. You buy a server with more RAM and a faster CPU. Think of it like hiring one world-class super chef. It is easy to manage, zero coordination needed. But vertical scaling hits a hard wall. You reach physical hardware limits. It costs 10 times as much for twice the performance, and it creates a single point of failure. If your massive server crashes, your entire app goes offline. The alternative is horizontal scaling. You scale out. Instead of buying $1 million supercomputer, you buy $1,000 servers. Instead of one super chef, you hire 50 line cooks. You can always add more servers. Each server in a distributed system is fully independent. It has its own CPU, its own memory, and its own disk. No server shares resources with another. These independent servers are connected by a network. They coordinate entirely by sending messages to each other. There is no shared memory bus like inside a single machine. To the user, the entire distributed system feels like one powerful computer. When you open Hotstar, you see one unified app, not hundreds of individual servers. That illusion is the whole point. And critically, if one node fails, the system keeps running. Traffic is automatically rerouted to healthy nodes. The user experiences nothing. Horizontal scaling introduces a massive new problem. Coordination servers have to talk to each other over a network, and the network is not reliable. Cables get cut, routers get congested, packets drop. When you have 10,000 servers, hardware failure is a daily certainty. Drives will fail, memory will corrupt, servers will go dark. A distributed system must be designed assuming failures will happen constantly. Because the network can fail, we have to make hard choices. This is the CAP theorem. A distributed data store can only provide two of three guarantees: consistency, availability, and partition tolerance. A partition is a communication break. Server A and server B are running, but the network link between them is cut. Because networks always fail, any distributed system must be partition tolerant. You cannot choose to not have partitions. A partition has happened. A user requests data from server A. Server A knows it cannot reach server B to check for updates. Server A must make a choice. Choose consistency or choose availability. If you choose consistency, server A says, I cannot guarantee the latest data, so I will return an error. The system is consistent, but it is no longer available. This is a CP system, consistent and partition tolerant. If you choose availability, server A says, I cannot reach server B, but I will give you my most recent data. The system stays online, but it is no longer strictly consistent. This is an AP system, available and partition tolerant. When a partition happens, a CP system returns an error. It refuses to serve data it cannot guarantee is current. An AP system stays online, serving the most recent data it has, even if that data is a few seconds stale. ATMs are CP. If the ATM cannot reach the central bank, it shuts down. It will not risk letting you overdraft. Swiggy's catalog is AP. If nodes lose sync, it is better to show a 5-minute-old menu than to crash the app. Choose CP when wrong data is catastrophic. Money, identity, medical records. Choose AP when staleness is acceptable and availability is everything. Catalogs, feeds, counters. Let us tie it all together. 50 million users hit Hotstar. Vertical scaling failed long ago. The load balancer receives the tsunami of traffic and spreads it across the server fleet. If 10 servers crash, the load balancer routes around them. the users notice nothing. The application servers then talk to a distributed database replicated across multiple data centers. A network partition occurs. Hotstar streaming is an AP system. It keeps serving video manifests even if view counts are temporarily out of sync. The network heals. The databases sync up in the background. Eventual consistency is achieved. Zero downtime for users. That is distributed systems. You understand why vertical scaling has a ceiling. You know that horizontal scaling introduces network complexity. And you understand the CAP theorem trade-offs. Next video, sharding. How do you actually take a 10 terabyte database and safely split it across 5 servers? We cover consistent hashing and database sharding. Link in the description. Subscribe to ByteLearn for one concept per week. Under 8 minutes, interview ready. Hit the bell. See you Wednesday.